Okay, so 2.2, polynomial functions of higher degree. We are going to talk about behaviors of things. We are not necessarily going to talk about exacts. So you don't worry, things are not very hard here. Okay, so continuous. You need to know the difference between continuous and discontinuous. Continuous is a nice smooth curve. I can draw this without lifting my pencil. I got nice curves. See that? Yep. This is a continuous curve. Only smooth curves. That's continuous. This is not continuous. I think it's pretty obvious that this graph on the right is not continuous, correct? There's a big break in it. The one on the bottom, though, is what function? Absolute value, because it's that v, right? It is considered a discontinuous function.
Because it has a break.
It doesn't technically have a break, but it has a complete change. It's not a smooth curve. It doesn't have a break in terms of its continuity. It does have a break in terms of like its rate of change because they're completely, these two lines are perpendicular.
Wait, what is that one called?
This is continuous and discontinuous. This is continuous on the left, and this is discontinuous on the right. Or not continuous. Polynomial functions are nice, smooth curves. So an absolute value is not a polynomial. And this would be a piecewise function, one where you have a part and a domain, a part and a domain. This would be, and piecewise functions are not continuous either. Huh. Polynomial functions are one nice, smooth function.
If I could do that the rest of the day, I would know. Yeah, that's easy.
Are these slides like from the book? Where do you get these slides?
I make my own. I usually, if the book starts with one, I'll maybe start with what they have, but I'll go to the book and cut and paste and stuff like that.
Then that's their comma right there.
If the only smooth, there's a comma right there. Yeah, it's even like. Okay. Why are we having a whole discussion on not this? Okay, so this light one is x squared. The darker one is x to the fourth. What do you notice about the two?
The x to the fourth is flattened.
It's flattened. Now it technically it doesn't have a constant. No, that's what I was getting to. If I zoom in and in and in and in and in, it gets closer sooner to the x-axis, but it still only has one x-intercept. What do you think would happen if I had like x to the 20th? It almost looked like it was a box, wouldn't it?
Yeah.
But it wouldn't be. If we zoomed in, if we put it on our calculator and kept zooming in, we'd start seeing the curve. Okay? So the higher degree, the flatter the curve appears. X squared is an even function, yes? Okay? All even functions start and end in the same place. All even parent functions, that means just x squared, just x to the fourth, just x to the 20, nothing behind it. They look like a what? Parabola.
Which about?
Okay? That's with nothing behind it. Everyone clear on that?
Yes.
Yeah.
Once I start putting other things behind it, I start getting more movement in it. Okay, on the right.
Wait, do we have to say, are those continuous or non-continuous or not?
They're both continuous.
They are.
Yeah. They're both polynomial functions. We were just talking about that.
Is a polynomial function always continuous?
Yes. Okay, so this is an odd function. How do I know this is an odd function on the right?
Because the n is odd number.
Yeah, but looking at the picture.
It goes opposite.
Opposite direction. It starts and ends in opposite directions, yes? Okay, so x cubed is the light gray. X to the fifth is the dark gray. Did it follow the same procedure? The higher the degree, the flatter the curve. Okay, now again, guys, this is not constant on the x-axis. If we zoomed in and zoomed in and zoomed in, you would see that it only touches right at 0, 0. Okay? You just do that later. Okay. The larger the curve, the larger the exponent, the degree, the flatter the curve. That's basically all you're getting out of this whole slide.
That's what I put.
The larger the exponent, the flatter the curve. Yep.
X to the 27. Can I draw one of those graphs?
Yeah, do it quick.
Yeah, it always starts off easy.
Okay, it's gonna stay easy today. Okay, this is an odd function. Why is this odd?
Because
Which one?
it
Both.
starts, it starts and ends at a different place.
It starts and shh.
I was really
girls.
confused when you were pointing.
It starts and ends at the different places. Yes, different
Yeah.
directions.
Yeah.
Okay, now this is the leading coefficient test. You need to know that word. The leading coefficient test determines whether the graph of a polynomial function eventually rises or falls. It only tells you the end behavior. That is why everything in the middle is dotted. The leading coefficient test only tells you the end behavior. It tells you nothing else. So, on the right, the left, this is left, on the left graph, was my A positive or negative?
Positive.
Why?
Because it's going up.
Because it ends going up. On the right, was my A positive or negative?
Negative.
Negative because it ends going down. Did you already know this stuff?
Yeah.
Yes. Did you know the leading coefficient test?
Yeah.
Well, you knew it. Did you know the name?
No.
No. So when it asks you for the leading coefficient test, you do not have to write it like this. You write it just like this. It will say, use the leading coefficient test to tell you the end behavior. A lot of words for that.
So you literally just put an up arrow down there?
Yeah, because it's going to start down and end what?
Up.
Up. And then when it's negative, it's going to start what?
Up and
and
then
then
down.
Down. When I talk about end behavior, it means the graph starts. It always starts negative infinity, yes?
Yes.
So it started up and it's going to end
Down.
down.
So it goes by what?
It goes by A.
The leading coefficient.
Yeah.
I'm
Whether the leading coefficient is positive or negative. Tells you where it goes.
Oh my gosh, I get it.
That A that we've been talking about for like 4 weeks,
In
right?
like vertex form.
Yes.
Oh, got it.
Your vertex form, your A. But we're not just talking about vertex form. We're talking about any form I give you a polynomial. If the leading coefficient is, but you have to write it in order. Yes? Okay, you have to write it in order. And if the leading coefficient is positive and it's odd, it's going to start negative and end positive. If the leading coefficient is negative and it's odd, it's going to start positive and end negative.
I love how good you trace this line.
It started really good. Okay, now, are these odd or even?
Even.
Why?
Because they both end on the same side.
They end on the same side. You don't even know what degree, but you know it's even,
But the
right?
numbers after the X are
Okay,
different.
so was this A positive or negative on the left?
Positive.
Because it's ending where?
Up.
Up.
It's straight.
A was what?
Negative.
Because it's ending
Down.
down. Is that the same for, let's see, absolute value? Think back 2 weeks ago when we did absolute value. Yes? Was it the same for the square root?
Yes.
Yes. Was it the same for, well, we did cubic and quadratic and like, it's the same for all of them. What?
Wait,
Wow.
what do you mean?
No way, you're lying, you're capping.
If it is negative, the graph ends going negative. No matter what it looks like, the right side is going to end going what?
Down.
Negative. Now, again, the leading coefficient test only tells you what behavior.
End.
Do not use it for anything else. It can't. It doesn't tell you anything else. It tells you whether it opens up or down, if it's even or odd, or it tells you where it ends.
So if it's even, it ends in the same place.
If it's even, it always starts and ends in the same place. Always. No matter what. No matter what the middle looks like, it will always stop and start in the same place.
Wait, what do you mean?
Like the,
The directions.
I thought you said it was even on the last slide, but it started
No.
down.
No. This is not even.
there's a negative.
This
You
is
have a
odd.
plus there.
This is odd. That's positive, not even.
How do you know if it's even or odd?
I'm confused.
Okay. If a function, how do you know the degree of the highest degree of the polynomial tells you whether it's even or odd. So if it's an odd number, Tori, name me some odd numbers.
3,
Mine look better.
3, 5,
7,
7.
There you go. If the highest degree in there is a 3, 5, 7, 9, it's odd. It's gonna start. It's gonna look like this. It's gonna
But how
start
do
and stop.
How do you know
You
from
can't
this
see.
that that's odd or even though?
Because it's not. It's ending in two different. It's starting negative and ending positive. So that's an odd function. Odd functions do that. That's what they do. Every odd function starts and stops in a different direction. Every single one. So that's how I know it's odd. How do I know this one is even?
Because they
Because
both
they
end
end
in the same
the same
direction.
They
direction.
end in the same
Are
direction.
you
Okay.
sure you don't want me
Let
to
me
go
write
back
that
to
down now.
your
I am
first period
positive.
math class?
I am positive. Okay. Describe the right and left hand behavior, or just describe the end behavior. Do not say it in words. Do it on your paper. Arrows.
Kappa.
You can write the equation if you want.
No.
On your homework, you can't pass on the equation. That's your only work. You're gonna pass on full credit then.
Are we looking at the exponents or the? Wait, never mind.
You're looking at your A. Is it positive or negative?
That's it?
That's it. Well, you're looking at the highest exponent to tell you if it's odd or even.
Oh, so we do look at the exponents. Okay.
Yeah. Odd or even gives you
Wait a second again.
Are we supposed to figure out
Which
our
one
A?
was it say again?
No.
Is it the,
the
first,
first-
one? The first one.
the leading coefficient is your A.
And so 3 is an odd number, so the graph would be odd.
Wait, so the exponents tell you if it's odd or
The highest degree. Not all of them. The highest degree.
the highest degree.
Hi, sorry for disturbing. I'm doing a readers report and going around to classes, seeing if any students want to be a part of it, or teachers.
I don't know what that is. Anybody want to be a part of it?
Her report.
I don't wanna
Go out there.
Go
Go
We're
out
doing
there.
special talent here.
Let's go.
Something like this.
Well, I think my math is special talent.
I
Go.
said you keep teaching.
Go.
Adam
We gotta keep
said that
going.
he's great at math. That was his
Have Miss
special talent.
Mick on it since she's new. Go ahead.
No, we're gonna
It'll
do
only
it.
take.
No.
It'll
There
only
you go.
take like a minute.
Yeah.
You can
It
do it
does-
right
it
here
does-
because this is my
Oh,
special
yeah,
talent.
yeah. Do it.
Do it right here. This is my special talent. Okay, so I have negative x cubed. Am I odd or even? Odd. So everybody show me what an odd graph looks like with your hands. I didn't say which one, right? It's like this. Correct?
Yeah,
Okay.
you're doing that in the video.
Okay, so
I didn't
It's
start
odd.
yet, so.
and it's negative. Yes?
Yeah.
So it's gonna end what direction? Down. So it had to start what? Up.
Shabbat.
I'm going to state your name and your
Wait.
talent.
My name is Shannon.
I didn't even start yet, so.
Oh, well, you know my name. Okay, anyway, you can record me this and you can like switch it around. It's editing.
I didn't even start doing it yet.
Well then tell me when you're starting.
I'll be pointing to you.
Okay.
Just press start.
So is it odd or even?
Even.
Even, because it's a 4.
Yeah.
Well, first of all, is it in the right order?
Yeah.
No.
Yeah, it is.
Yeah. 4, 2, yeah.
Let's
Yeah.
restart
You
the
had
video.
it.
It sounds dumb. You can delete that.
Is it odd or even? Even. So show me what even look. Show me what even looks like.
No, actually, go like that.
This, right?
Don't get in that video.
Okay. So even looks like this, but it's positive, so it's gonna what?
I'll go where where you at if you want.
Please, you can delete that one and do the next.
Okay. Next one
Wait,
we
why
got
are they both up? That's
because
why I
it's
don't
even.
Because they end on the
Even.
same side because they're
Delete
even.
the-
But did it go down?
Oh,
Did it
okay.
go
Oh,
down?
wait,
If it was what, Maddie?
I already zoomed in on him, so he
If it was negative,
The A is positive, so
the A is positive.
Oh,
Okay.
I see. If it was negative, they would go down.
Yes. Yes, yes.
Okay,
The
wait.
next
Okay.
one be like this.
The next one, is it in order?
Yeah.
Yes. Always need to make sure it's in order, yes?
Yeah.
Is it odd or even?
Odd.
Show me odds. Show me odds.
Shabbat.
Show me both of them.
But it starts down and
Okay.
ends up.
So this one is positive, so it ends up, so it started
I had that.
down. Did you get it?
I got
Yeah.
that.
Woo!
This on the
You
whole
do
thing.
quick your name and your
I
talent.
had it.
My name and my talent. My name is Shannon Mick, and my talent is math.
Yeah.
I go. If any student wants to come,
My name is Carly and my talent is having a C+ in math.
Yeah.
Maddie and my talent is singing.
Okay.
Go sing.
Okay, we need to keep going. We need
it
to
only
keep going.
takes like a minute.
I know, but we need to keep going and
Sorry,
really have
none
a
of us
class.
want to miss math.
Sorry.
Yeah,
They love
that's
math so
important.
much.
Actually, no, I
Okay.
just won't understand anything.
I just want to pass.
Okay.
This better be all we have to do is
We're almost actually done with the whole slideshow. So, zeros of a polynomial function. Okay, if for a polynomial function f of degree n, just right here, the function has a function f has at most n real zeros.
What?
Listen, just
Oh,
listen.
so, man.
Okay, for any function right here, it has at most n real zeros. N is right there. So if that n was 6,
There's
How
6
many?
zeros.
it would have 6 zeros. Now, it actually has exactly 6 zeros. But these, what did I say right here?
Real.
Real.
So it can be negative.
Those sit, not negative,
Oh.
imaginary.
Where did
Okay.
you get 6?
If I said x was 6. Like,
Oh, okay.
if x to the 6. Okay? There are actually exactly 6. But they don't have to be all real. Yes.
What? Okay, I don't know if this is even possible, but what if it's negative 6?
If it's negative 6, that's a whole different function.
That makes it
Actually,
point.
if you have x, no. If you have a negative exponent reciprocates. So you have x, you have 1 over x to the
Yeah,
6,
we don't
which
know.
is
That's not what I learned in science.
You don't
no,
know.
you said
thinking
10 to the negative. You're thinking scientific notation.
Yeah.
Okay, so that is a rational function, and they have completely different graphs. Okay, so this isn't. Okay, so this one has actually exactly 6. We can't have more than 6, but I didn't say they were all real. Okay, so the next term says a graph of f has at most n minus 1 turning points of the graph. So if my x is x to the 6,
It's only gonna turn 5 times.
it's only going to turn 5 times. And what that means, these are also called relative minima or maxima or extremas, are points at which the graph changes from increasing to decreasing. So let's say I have that graph. I give me some nice. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? Oh, and that would have to be negative, right?
Wait, I thought it was 6 though.
If it's 6, what does it say?
Minus
N
1.
N minus 1. Okay, so the graph, and
So
then,
you always subtract 1.
yes,
To
always.
find them out of curves.
Okay, and at most, guys, could it have 4?
Yeah.
Yes. Could it have 10?
Yeah.
So then
No.
would your points
Can it
just
have
be
10?
down the
No.
No. I don't, nothing about points. I just said turning points.
Why can't I have 10?
Because the rule says at most, N minus 1.
Silly dude.
And
you
our
have
N
to have
is,
at least 11.
this is x to the 6. So at most, I can have 5 turning points. I can have 4, I can have 1, I can have 5, but I can't have 0, first of all, then that's a linear equation.
So if the 6 was turned into a 10,
Then I could have 9.
8, 7, 6,
Yes.
5, 4, 3.
Yep.
Good job.
Okay. And this right here at these extrema, this graph switches from going from what?
Max to min.
Increasing to
Decreasing.
decreasing, increasing, decreasing, increasing, decreasing.
So your arrows would be up, down.
No, because it's even.
No,
so they
it's
both
even.
max
That
out.
would be
Oh,
it'd be down, down.
down, down. My
And there
bad.
has to be other stuff like that. Because
But
if it was just x to the 6, it would just be a
how
problem.
could you make that down?
I put a negative in front of it.
I know, but 1, 2, 3, 4, 5.
1, 2, 3, 4. Did I count one? 1,
You do have 5.
There's
4,
5 points.
5. Yeah, there's 5.
So
There's
it's
5
still be even.
Yeah.
But then if the negative is in front of it, you want it to be odd.
No, if the negative's in front of it, that opens down. That's all that
That
tells
just
me.
means
Oh.
negative.
Okay. Now in
So,
red,
wait, how did you decide that it opened it down?
I just
So it,
made up an equation. But yeah, it had to put a negative in front of it so it opened down.
Okay, wait. I thought the 6, the exponent of. Oh, wait.
Then decide to go over
Okay, doesn't the exponent of 6 change to 5 now since you?
No, it doesn't change to 5. It just tells you there's 5 turning points.
Okay, well since it is 6, shouldn't the arrows be up?
If it was positive, but it's not positive.
She drew it negative.
Okay. Okay,
10 minutes left in class.
so right here in red, and you don't have to write it down, you do need to know it. Finding the zeros, the x-intercepts, solutions is one of the most important things you will ever do in math, no matter what math you do.
I think you just said that
Because
before I
of the fact that that's what we're always looking for, yes?
Yeah.
It's a solution to a problem. So the solution to a problem is where it hits the x-axis for the most part. I think, oops, I hit the wrong arrow. Yeah, we just have this, and I think that was it. Oh, example. So you have enough to go through probably about half of your assignment. If you, honestly, guys, we have covered everything in this section already before. They're just putting it in different words. So wherever you feel comfortable stopping, but if you get to one, just a second, if you get to one you're stuck on, go look at the next section. Maybe you're not stuck on that one anymore. Please staple your homework and turn it in. Yes,
Can I turn in the rest of my homework at the end of the day?
yes. If you're not done and want to complete it, keep it and get it turned in. I will be putting grades in this weekend, but it will just stay that way until the next time I go in. I will
Is it-
still accept it.
Oh,
Oldest goes on top, right?
really want to be on the down.
Yes, oldest goes on top.
Exactly. So
What?
And you're,
you want to be here.
Sit down.
yeah, that's fine.
Well, we've all got down, so down.
I have a question. Can